Hello everyone, I'm Leandro and we are here on our webinar to talk about USP 800. We talked about hazardous drugs on healthcare settings and we are on our third episode. I'm here with Jeff Spink, CEO of Analytics Corp, Jack Simila, our Client Service Manager, and Andy Teague, our CIH and Lab Director. So Jeff, on the last episode, we talked about how our kit looks like and what people should expect to see inside of the sampling kit. Can you summarize what we talked on the last episode?
Yes, I can. Thanks, Leandro. Well, welcome everyone. This is our third webinar, and on USP 800, we're trying to go through the entire program with you to help better understand it. Our webinar number 2, we spent a lot of time talking about sampling for the hazardous drugs in the healthcare setting. The USP 800 document that I've been showing everyone, and it's on our website, specifically talks about areas to sample and how to sample. And the sampling process that they specify is a wipe sample. As you said, Leandro, Jack talked about our kit. You might remember the kit looks like this, and it has the sampling supplies inside to do the wipe sampling. And that's specifically what USP 800 calls for, doing wipe sampling to make sure the healthcare workplace setting is clean, that we don't have hazardous drug contamination. But the other thing that we touched on, and we got a lot of feedback from the webinar number 2, was on the possibility of doing air sampling for these hazardous drugs. Again, although USP 800 specifically talks about wipe sampling, there seems to be a lot of interest on air sampling. Air sampling, much like we do for any industrial hygiene type of project. We send out a pump, and we offer that at no charge. We provide the media and so forth, and we can do that for these hazardous drugs. So, Jack, if you could take a couple of minutes and just talk a little bit about the air sampling program, how you do the sampling, and maybe show them the pump and so forth. That'd be great. And then Andy, if you could just kind of go from there with once you've collected the sample, kind of how does that translate into a result for the client?
All right.
And then we'll get back into the shipping and receiving process. We want to spend some time on how do we receive it, what happens with your sample once it gets to the lab, and then that'll be pretty much for today. So Jack, could you just talk about air sampling for a minute?
Sure, Jeff. We have a really nice program for our customers that we can lend personal sampling equipment to them at no charge for the rental of the equipment. It's a free program, and based upon the type of analysis they're looking for, what drug are they going to collect, we provide we can provide the media, and we can provide the pump pre-calibrated with that particular media, so that it turns into like a plug-and-play type thing for the customer. They'll receive the personal sampling equipment already pre-calibrated. They put in a calibration media in place, check it with a field rotometer that we will provide to them, and then they're ready to start sampling. And just to show a little bit of how it's set up, this is our personal sampling pump line that we use in our program. They're AirCheck 52s. And this is what the cassette would look like on the cassette holder. And you can't see the whole system, but these are connected together. So you have a pump that pulls air calibrated at a certain amount, say 2 liters per minute. And then you connect your cassette so that the inlet is facing down, and you're connected to the pump. You clip it to your collar or to the worker's collar, And the reason for this is you want this sampler to be in the breathing zone area of the person, because what we're looking for is occupational exposures to whatever contaminant may be present or that you're sampling for. And then you connect the personal sampling pump to the worker's belt, and they can basically move about their work area and be sampling the entire time that is required. And it's that easy. And when you finish your sampling, you just disconnect, you turn the pump off, you disconnect the pump from the cassette, cap it up, you put it in your shipping container to send back to the lab. But first you're going to fill out your chain of custody, and just like you would with your surface sampling, matching your cassette with the chain of custody and the type of analysis that you want. And then you send it back to the lab. It's that easy.
Good, yeah. So once you've collected the air, Andy, give them a quick summary of how that translates into a result. You know, what are we going to give them? And I know we're going to talk about this a lot more in detail at a later date, but just to kind of complete the process, how and what's going to happen then?
Okay. Well, as Jack mentioned, the pumps are pre-calibrated before we ship them. We ship a device for you to check the calibration on site to make sure that the effective flow rate hasn't been altered by anything that happened during shipping. And we advise you to check that at the end of sampling also to make sure that nothing's happened to alter the sampling rate during the course of the sampling. Jack mentioned a very typical flow rate is 2 liters per minute. We sample that from the breathing zone for the duration of the exposure, whether that's an hour or a 8-hour shift or a 10-hour shift, sample for the duration of the exposure. And the air is being pulled through a filter, and the filter pulls out aerosols, particles of the hazardous drugs. And you don't have a lot of volatility among the hazardous drugs that we're being asked to test. So filtration is a suitable way to trap them. Knowing the sampling rate that the pump is running at, again, typically 2 liters a minute, and the duration of the sampling from your record of a start of sampling time and an end of sampling time, you know the number of minutes that the sample was collected over. Let's make the math easy. 500 minutes of sampling at 2 liters per minute means 1,000 liters or 1 cubic meter of air has been pulled through the filter. We'll get into the testing later, but we test the sampling devices, filters, sorbent tubes for volatiles, whatever it is. We test for the mass of the contaminant. And the mass of the contaminant expressed in terms of micrograms divided by the air volume expressed in liters that comes from that liter per minute times sampling minutes. Micrograms divided by liters gives you a concentration, and that is equivalent to milligrams per cubic meter. Or for some of these tests that are quite sensitive, we might express the result as micrograms per cubic meter so that you don't get a result with lots of zeros to the left between the decimal and the significant figures. So the result would be expressed as a concentration in micrograms per cubic meter or maybe milligrams per cubic meter. And that is the value against which you would compare the measurement. That's the measurement you would compare versus whatever acceptable, whatever limit has been established for an acceptable exposure. If the manufacturer of the drug has established an exposure standard of 1 microgram per cubic meter, and we test the samples and find 2 micrograms on them, 500 minutes at 2 liters a minute gave us a cubic meter of air. 2 micrograms divided by 1,000 liters sampled gives us 2 micrograms per cubic meter. That means the exposure measurement was twice the recommended exposure level.
Perfect. Okay. That's exactly what I wanted, just a little introduction. And that was great, Andy. At first it may seem kind of confusing, but we're going to go through it several more times before the end of our webinars, Leandro.
Let me throw in one thing, Jeff. It's all about representativeness. You're pulling a cubic meter, in that example, you're pulling a cubic meter of air from the zone in which you're drawing your breaths. And so that constant sampling during the duration of the sampling gives you a representation of the concentration in the breathing zone. And your exposure standards are based on what we know of the toxicity of the compound and how much we estimate somebody breathes in the course of a day. What volume of air do they process?
Okay. Okay, so that's a quick overview, Leandro, of kind of the whole sampling process, much of what we talked about the last time. Now, now you've collected your samples, be it an air sample or, you know, a wipe sample. And if you remember, you're going to get 2 wipes. One you're going to wipe with wet, one's going to be dry. You're going to put them into the test tube and send it back with a label on it. That's going to go back into the box with the chain of custody. If you've done an air sample, you can put it in the box as well with the chain of custody. And we provide you with a FedEx label, overnight delivery, put it on the box, drop it off at FedEx or have them pick it up, and it'll get overnighted to Richmond, where our laboratory is located. And that kind of starts the process of what we call receiving or sample login. And Jack, I'd like you to spend 5 or 10 minutes, if you could, please, to really explain the whole process, because, you know, people know that I've taken this sample and you provided me with the pump or the media, but what happens? And, you know, how do I know that it's, you know, everything that's going on? So today we'd like to really explain the receiving process, and Andy will talk about the preparation of the samples and some of the nuances, why we ask you to collect maybe 2 sets of swabs and things like that. So Jack, could you spend a few minutes to talk about the, you know, right from the beginning when we go to FedEx and pick up the samples, please?
Yeah, sure, Jeff. And that's a good question, because if I'm a customer, what happens once I put my sample in that box and I put the shipping label on it and I take it to FedEx?
Yeah.
What happens to my sample? How do I know it's being taken care of? How do I know that somebody didn't mix it up with another sample and I'm getting true results? So we have a pretty elaborate verification process that we follow in our lab, and it starts with picking up the samples at FedEx. So we don't even wait for FedEx to deliver to us. What we do is we'll go down to FedEx and we'll get in line with the other trucks down there, and we'll go in and sign for our packages ourselves at the FedEx hub. And once we sign for the packages, we load them into our van, we bring them back to the lab, and that's where the real verification steps, you know, begin. So once the packages come back, even though we scanned them at FedEx, or FedEx scanned them for us and gave us a receipt for them, we scan all those packages one more time, or another time, I should say, in our lab. And this scan is an incoming package scan that we do. So this way we know, and what we do is we match this incoming package scan against the FedEx scan that when we picked up our samples. So we know that we have all the samples that we signed for at the FedEx hub. We have them in our lab now because we do a verification there and check that against them. So once those packages are scanned in, the supervisor of the receiving department will deal out the packages to the different receiving personnel in the lab. And when they receive the package, they'll receive 1 or 2 or 3 packages at a time. They only open up 1 package at a time. And when they get that 1 package, they scan it again. Now this scan is telling us that, hey, we received the package. Now we know that receiving personnel received the package and they opened it up. And again, what we do at the end of the day or at the end of that shift is we'll match up those 2 reports together to make sure that every package that we scanned and signed for is actually been opened in our lab. And if there's discrepancy there, then the manager of that department will work on it right away. But once the package is scanned and open, we do a verification step. We take all your samples out, and remember, each workstation can only have one package open at a time. So they'll take all your samples out of that package, and they'll lay them out on the table, and they will take the chain of custody that you provided in the shipping package, and they will do a verification of each sample against the chain of custody, just to make sure everything is there. And once that's been verified, they sign for the document that they have all of the samples, and then they'll run a program that will produce barcodes for each of the samples that we verified. So if you had 10 samples or 2 samples or whatever, we barcode every sample, and then we put a master barcode on the actual chain of custody document. So we know that this chain of custody document goes with these samples. And once that is done, the samples are then moved over to what we call our login station. And we have another receiving personnel at the login station, and they'll take those samples and they'll do a second verification. They'll go back in and they're going to check and make sure every sample it matches the chain of custody, and they'll also check each barcode to make sure the barcode matches the chain of custody. So barcode 1 is on sample 1, barcode 2 is on sample 2, and so forth. And at that point in time, they'll key in all the information we call log in the samples. They'll log in the samples to our system and assign the test code, the appropriate test code to it during the login. Once that's completed, they place these samples in another bin for verification again. And so the next step in the process is we're going to verify through a barcode scan and a computer program that our IT department wrote, that each of the sample barcodes that were placed on the tube or on the sample itself is the appropriate barcode, and it matches what should be what's on the chain of custody and what would have been logged into the sample. So at this step, a person that hasn't had any contact with the samples earlier will take the samples, will scan it with a barcode reader, and when it does, a screen will pop up and it'll say type in the client ID number. And so whatever the ID number that the client assigned to it, we type in. Now the computer will do a match, and it'll match up against what we logged in previously. And if everything matches, then we know we put the correct barcode on that sample. So we're good there. Every single sample in the lab goes through this process. So if we have 300 samples one day, we will do the same thing over 300 times, or however many times it's necessary. And once a group, like say you submit a chain of custody to us, you have 10 samples on there. Once we verify all 10 samples are correct, when we do the last one, it'll automatically print out what we call an internal chain of custody. And it'll be a sheet that will print out. It'll be electronically signed by the person who did the verification, because they put their PIN number in the system to, as a way of signing for that sample, those samples. And we take the internal chain of custody, we put it in a Ziploc bag with those samples, and then we place it in a bin that we have inside the receiving department that's for that particular area of testing. So for instance, if it was USP 800 testing, we have a bin especially for USP 800 drugs. And once it's in the bin, the lab is notified electronically that they have samples. They can come down to the lab and they'll go to their bin, they'll take their samples out, and they're going to do a verification. And what they do is they'll take each sample out, and they don't have to do it in any kind of special order or anything like that. And they're going to scan it with a barcode reader. And they'll scan it, set it aside, take the next sample, scan it, set it aside, take the next sample until they go through the whole process. And once they processed all their samples and they scanned them all, they'll have another report come out that gives them a list of all the samples that they have, and they'll know that they have everything that they're supposed to have as far as the number of samples are concerned. And the reason why all this is really is important is that if you follow these steps and you do and the procedures the way we have them set up in the lab, we don't lose any samples. We don't mix up any samples, and we account for that sample at all times. Samples cannot leave the receiving department once they come in until the very final step. And basically the final step when the lab comes in and does their scanning, they're basically signing for those samples because they enter their PIN number also. And then they'll, once they scan all those, all the samples, and then their report prints out, they've signed for those samples, they can now take them to the lab for verification. And there's not for analysis. And then there's a few other steps or a few other things that we do in our lab, Jeff, that I should mention, because, you know, a lot of times people, we've had cases where people call us up and they said, hey, where's our, you know, I had 5 samples in that package, but you only, you know, gave me a report for 4. And, you know, and we will say, well, you know, you had 4 on your chain of custody. And let me tell you a few of the steps that we go through to ensure that something like that, you know, doesn't happen. And what happens, Jeff, is when the packages come in, and we get various packages, cardboard, the USP 800 kits, and things like that, we're required to break down every single package flat. So all wood cardboard has to be broken down flat so that there's no way a sample can get underneath a flap, you know, or, you know, stuck in there in packing material or anything like that. We have a separate container for the flat packages to go into. And we save that container for 3 days, by the way, just in case anybody has a question about that. The other container we have is packing material. All packing material goes into this box. So if somebody were to call and say, hey, you know, I had 5 samples in that box and you only gave me 4, we can go back to that container with the packing material, and we can go through it and we can look and see if, hey, maybe we made a mistake and there's a sample in there. So we can go back and we can check on things like that. And we hold all this stuff for, you know, a period of 3 days. And if we ever need to go back and check, we got plenty of time to go back and do that. They're just some of the extra things that we do above and beyond that people, you know, don't know about. And that when you send your samples to the lab, it's always good to know, hey, I know my samples are being taken care of. I know they're being verified, they're checked, they're taking extra steps to make sure that my samples aren't lost in the process. Because really a lot of the times when things happen, it's kind of like in the beginning, if you were going to lose a sample or misplace a sample. And I can say that is something that doesn't happen in our laboratory.
Yeah, it's incredible, Jack. I know that we've tailored a lot of what we do off of, you know, like forensic drug testing, where, you know, we are ready to defend our results in court, that there's never a breach in the chain of custody. And so it gives me a lot of comfort to hear you go through that process. And I think what we believe, Leandro and Andy, you can add to this, is that unlike, say, an environmental sample where you get a bottle of water or a bottle of soil or whatever, you got a couple chances at it, so to speak. With an air sample, you get a filter, and once you digest that filter or do something with that filler, that's it. You have one chance. And so, you know, we've been audited a lot, and a lot of people say, wow. And I mean, and I believe it's, someone's told me, Andy, Jack, you know, we do like 18 steps of verification, you know, like, why, you know, what, and I answer it, or we answer it, you know, we don't want to make a mistake because we only have one chance. So hearing you go through it, Jack, I think the people will feel quite comfortable. So that was great. Thank you. As Jack said, now your sample has been received. It's in a bin. The lab's going to come down and start the analytical process. So maybe, Andy, you could then walk us through what happens after it's been received, and the manager from the preparation sample prep department comes and picks it up. Let the people kind of know how and what goes on there.
Okay. Well, typically the person that's going to be doing the sample prep is the one that comes and takes custody of the sample from the receiving area. They transport it in the process that Jack described. They transport it into the area of prep, and there, yet another check is performed when the samples are being prepped. There's an independent analyst that verifies the prep process, that the prep process that's going to be applied is appropriate for the tests that have been assigned to the samples. Jack mentioned, we talked earlier about sample testing resulting in a massive sample. Almost all of our tests are performed by putting the contaminant, the hazardous drug, or whatever it is, into solution so that we can handle conveniently, you know, on our instrumentation, a homogeneous representation of a sample. If we have a sample extracted, we typically are only testing a small portion of the extract, but we need to make sure it's representative. And the way we accomplish that is by dissolving, putting into solution that contaminant, such as a hazardous drug, in a solvent or a solvent mixture in which the chemical is freely soluble. To some extent, this is why you see instructions from us about collecting multiple samples in some cases to represent for measurement of an array of contaminants, hazardous drugs, for instance. Not all of the hazardous drugs are soluble in the same solvent mixture. When they're not, we're asking you to collect multiple samples so that all of one sample can go through an extraction procedure and be put into solution for testing in an approach that works for that hazardous drug or that combination of hazardous drugs. But we don't have, we shoot for a universal approach if we can accomplish it. We don't have a universal approach for all hazardous drugs or all metals or all volatile organics. We just don't have universal approaches. So the sampling needs to be consistent with the extractions and the analyses that are going to be performed. But again, we take that sample, double check to make sure the prep that is going to be applied is appropriate based on the tests that are assigned. And then the sample, the contaminant, hazardous drug, is put into solution by adding a solvent to that, to the sampling device, and typically by energizing it somehow. Shaking, agitation, sonication, it varies with the media and the contaminant and the test that's going to be performed. But we prep the samples in a fashion consistent with the way we validated the analytical approach. Have I covered it, Jeff?
So when I look at my chain of custody, this is the chain of custody here, and I see that there's a number of drugs, and we call that group 1. I'm led to believe now from what you said that group 1 will get prepped.
They are compatible in a single prep.
Correct. Then the group 2, in this case, is gemcitabine, meaning gemcitabine cannot be prepped and run with the first group.
At least to this point, that's where we are, yes.
Okay.
And the platins, we're testing the platins based on their elemental platinum composition, and we're treating that with separate prep. So to this point, the platins are treated as a separate sampling and a separate analysis.
Yeah.
And there are other drugs. When you add other drugs onto what's being tested,
the hormones.
Hormones are an example. But when you add other drugs on, they may fit a prep that we're already applying. The drug may fit into a prep that we have already established for another array of drugs, and that may be the array you're interested in, but it may not be. So if it's not on the list, that's the double check that has to be the starting point for before sampling.
Sure.
Air or wipe samples, same thing.
So it's really the same process, whether you put these Q-tips into the solution or you put Jack's filter into the solution. The same thing's happening. You're pulling the compound of interest, the drug of interest, you're pulling that off of the sample media, getting it into solution, and then that solution is what's going to be analyzed.
Just like the air sample or the wipe sample is a representation of what's in the air or on the surface, we get it in solution so that when we test a portion of that sample, it's representative of the whole.
Yeah. Okay, yeah, that's great, guys. So where we're at now, Leandro, is that we've sampled. Samples have been shipped to the lab. Jack and his group have received them. The lab that Andy oversees, the lab has prepared the samples for analysis, and that kind of concludes our discussion for today. The next webinar that we're going to do, I think, Andy, you're going to move the sample from prep into the actual analysis.
Okay.
Explain a little bit about the instrumentation, how the review process works in the analytical area, preparing the report, and then getting the report or the results out to the client. So with that, I don't know, Jack, Andy, Leon, anybody got any other things that they want to touch on now? Otherwise,
I'm good.
We'll call this the end for now, and see you in a couple of weeks for our webinar number 4 on analyzing your samples.
Yes, Jeff, and just to remind our audience to click on like this video and subscribe on our channel so they can get uploads in every video, every content that we put together for them. So please, if you like this video, click on like below here and subscribe to this channel. And we see everyone on the next webinar. Yeah,
that's an important thing. We actually email out the webinar, right, as well. But if you want to share it with someone else, you just go to our YouTube channel and you can watch there, right?
Exactly.
Okay.
See everyone on the next episode.
Thanks. Take care.
Bye.
All right.